Dear students, you are welcome in the Education Department at SHAHD Association. Our lesson today is grouping of resistors. Make sure to subscribe to our channel for more lessons and don't forget to activate the bell to stay notified.
We have two objectives today. We will recognize twin resistors that are connected in series and in parallel. We'll calculate the equivalent resistance in the two connections. In the Explore section, we saw some appliances that convert different types of energies into another. Now, we will take a new device. It's called resistor. The resistor is an electrical device that converts electric energy into heat energy. The resistor takes electric signal as an input and converts it into heat. The resistor has a physical quantity that is specific for every resistor. It's called resistance. The SI unit of resistance is ohm. This is how a resistor looks like. If we want to draw it in a circuit, we can draw this shape or this one. Now let's try to construct a circuit having a dry cell, a lamp, and a resistor. First, we will draw the dry cell as this shape. Then, we will draw the lamp as a circle having a letter. Finally, we place this resistor as this shape. How can resistors in series be connected? These two resistors are connected in series because the two resistors are one after another. The current has no choice because there is no branches. The main current that passes through the first resistor, it is the same as the current that passes through the second resistor, and so on. Now, we will move to the point on how can we group resistors that are connected in series together. All resistors can be replaced by one resistor having a resistance R equivalent. The equivalent resistance of all resistors in series is the addition of all resistances. So we write the rule R equivalent is equal to R1 plus R2 and so on. So let's do this example. The circuit to the right have two resistors of resistances 6 ohm and 4 ohm. If we want to calculate the equivalent resistance, we apply this rule. R equivalent is equal to R1 plus R2, and we replace 6 plus 4 is 10 ohms. So we write these two resistors as one resistor having a resistance of 10 ohms. How can resistors in parallel looks like? These two resistors are connected in parallel because they are connected side by side. Here the current has a choice because there is branches. The main current is not the same as the current in the first resistor, and it's not the same as the current in the second, and so on. We will do the same thing to the parallel connection. How can we group the resistors in parallel connection that have an equal resistance R equivalent? The equivalent resistance of all the resistors in parallel is calculated according to the equation. 1 divided by R equivalent is equal to 1 divided by R1 plus 1 over R2 and so on. We have an exception. If we have two resistors in a circuit, we can calculate it directly using this equation. R equivalent is equal to R1 times R2 divided by R1 plus R2. Let's do the following example. The circuit below have two resistors that are connected in parallel. R1 is equal to 20 ohms, R2 is equal to 30 ohms. So since we have two resistors, we can calculate the R equivalent using this equation. R1 times R2 divided by R1 plus R2. So 20 times 30 divided by 20 plus 30, it will give 12 ohms. So we replace these two resistors by one resistor having R equivalent of 12 ohms. Let's do another example. The second resistor and the third one, they are connected in parallel. These two, they are connected in series with the first resistor. All these resistors will be replaced by one resistor. We have to start by the second and the third one. They are connected in parallel, so we use this rule. R23 is equal to R2 times R3 divided by R2 plus R3. So 2 times 3 divided by 2 plus 3 is 1.2 ohms. Now we have the circuit. We have the first resistor and the resistor that replaced the second one and the third one. Now these two resistors, they are connected in series. So we calculate the R equivalent as R1 plus R23. So 5 plus 1.2 is 6.2 ohms.
Thanks for watching. If you like this lesson, make sure to subscribe to our channel for more, and don't forget to click the bell to get all updates.